Example 13. Now we're not solving trig equations, we're solving trig expressions. So this involves a lot of substitution. Cotangent and tangent, those are reciprocals of one another. So if you are aware of that, you already know the answer is 1. But if you wanted to use substitution so that you have a better visual, you could cotangent. We could substitute cosine of x over sine of x times tangent. You could substitute sine of x over cosine of x. Notice everything cross cancels, leaving you with 1. Looking at example 15, no, this is what I have written. That's not the problem, but we're going to use this Pythagorean identity to help us figure out what the answer is. I'm going to rearrange this in a way that at least one portion of the equal sign matches what they have here. You could add over cotangent. Okay, now I'm going to subtract over cosecant and subtract over 1. So moving cosecant over here, moving 1 over there. So subtract over 1, subtract over cosecant. Okay, this matches that, and this is the same thing as -1. So that's your answer for 15, -1. 17, we would want to substitute something here for cotangent squared of x plus 1. Cotangent squared of x and 1 is this Pythagorean identity here. If we added over cotangent to both sides, we would be left with cosecant equals 1 plus cotangent squared of x. Therefore, we can substitute a cosecant into these parentheses. I'm going to keep cosine, substitute cosecant into those parentheses. And you don't really need the parentheses anymore. All right, cosine, I don't want to change, but I want to change this to its reciprocal identity. Multiply that, you get this. And now we have a quotient identity. Your answer is cotangent squared of x. To begin solving 19, I wouldn't do anything with secant squared right now, but secant squared of x minus 1, we can use this Pythagorean identity here and rearrange it in a way to help us use some substitution. So in order to rearrange properly, you would have to add over tangent, subtract over 1. If you do those things, hopefully you have a visual of what we're going to substitute here. So by rearranging that Pythagorean identity, secant squared of x minus 1 is equal to tangent squared of x. Now, there's another way of rewriting this. We could say secant squared of x divided by tangent squared of x. I'm going to do a little bit of some substituting now. I see secant squared. Usually you want to change that to its reciprocal identity. So 1 over cosine squared divided by tangent squared. You almost always want to change that to its quotient identity. So sine squared over cosine squared. Okay, now since we're dividing fractions, we want to use the keep, change, flip method. Keep this, change the multiplication, flip the fraction. And here, those cross cancel, leaving us with 1 over sine squared of x, which its reciprocal identity is cosecant squared of x. Final answer. Example 21. Here's how you would want to start solving this one. First of all, do not use any substitution here for 1 plus cosine of x. That is not a Pythagorean identity because cosine is not being squared. So we're going to have to establish a common denominator here and subtract these terms. The common denominator is 1 plus cosine of x. This term 1 is the same thing as 1 over 1. And I'm now going to multiply the numerator and denominator by 1 plus cosine of x. If you do that, here's what we're left with. Now we can subtract our numerators. We can do 1 plus cosine of x minus sine squared of x, but I'm gonna rearrange this a little bit. There's our numerator. Here's our common denominator. 1 is still positive, sine squared is still negative, cosine is still positive. The reason why I rearranged that is because look here. Now we have a Pythagorean identity. We can use substitution. 1 minus sine squared is the exact same thing as cosine squared. So that's our new numerator, meaning we can now factor out a cosine. And look, I just rearranged the denominator because don't these now match? Meaning you can cancel. Your final answer is cosine.